strings word1 and word2 return the minimum number of operations required to convert word1 to word2. What are the operations that we can do? We can insert, we can delete, and we can replace. As you see in this example, for converting horse to Ross, we need to replace H with R, and we need to remove R and E here to get Ross from horse. How about like getting execution from intention? We need to remove T, we need to replace these three, and we need to insert U. So when we are talking about the minimum number of operations, so what we need to do, we need to iterate over every single a string, like every single character that we have here and every single character that we have in words, and compare them and get the like minimum value and store it somewhere. And we can use recursive functions, but we if we do that, we get the atomic set limit error. So there should be a better way to do that. One way like to deal with these kind of problems is using dynamic programming. Why dynamic programming? Because this way we can store the moves that we have made in previous steps in somewhere and use them for making decision about the next step. So let's see how we can do that. For solving these kind of problems, what we are going to do, we are going to have a matrix like m by n, which is m is equal to the length of the word 1 and n is the length of word 2. And these are the operations that we can do. What we are going to do, we are going to say if we have, let me remove this. So we are going to say how, like we are going to break down the problem to smaller problems and use them for the next steps. What do I mean by that? Let's say we had no words as word 1 and we had no words as word 2. How many steps do I need to take to get this from this? 0, because they are equal. I don't need to take any steps. How about like getting this from an empty string? I need to insert R here, so I'm going to add 1. How about getting RO from an empty string? I need to insert R and O here. How about, which is going to be here. How about getting ROS from an empty string? I need to insert ROS in word 1, which is an empty string, to get this. So it's going to be 3 insertion. How about here? What if I want to get an empty string from H? So it's going to be 1 deletion. How about getting an empty string from H and O? It's going to be 2 deletion. How about here? It's going to be 3 deletion. How about HORS? It's going to be 4 deletion to get an empty string. How about horse? We need to make 5 deletion to get an empty string. Okay, so let's see how we can get R from H. We need to replace H with R, which is going to be 1 move. How about getting RO from H? We need to make 2 moves. We need to replace R with H and we need to insert O. So it's going to be 2 moves here, right? How about getting ROS from H? We need to replace H with R and we need to insert O and S. So it's going to be 3 moves. How about getting R from HO? We need to replace H with R and we need to delete O. So it's going to be 2 moves. How about getting RO from HO? Because we have O here, so we just need to replace H with R and it's going to be 1 move. And so on, that we can fill out this table, and this is what we are going to get. As you see here, we can find a formula to get the value at the current step using the values that we had at the previous steps. Okay, how can we do that? For every single value that we have at this step, we are going to get the minimum of the three previous values. What is the minimum of 1, 0, and 1? It's going to be 0, and plus 1 that sum that up with 1 and put it here. So what is the minimum value here? It's going to be 0. 0 plus 1 is going to be 1. What is the minimum value here? The minimum value here is like 1 plus 1 is going to be 2. Let's fill out this table using this formula. So what is the minimum value here? It's 0 plus 1 is going to be 1. What is the minimum value here? It's 1 and plus 1 is going to be 2. What is the minimum value here? It's 2 plus 1, it's going to be 3. And as you see, we are getting the right values. So how about here? What is the minimum value here? It's 1 plus 1 is going to be 2. What is the minimum value here? It's 1 plus 1, it's going to be 2. And as you see here, if I change the color so you can see the difference here and here, let me change the color. You see we have a different value here, and that's not the right value. Why is that? The reason is we have the same character that we do not need to make any changes. For dealing with these kind of cases that we have the same character in word 1 and word 2, what we are going to do, we are not going to use this. We are going to have another formula for that. We are going to say at matrix I, at index I and j, if they are equal, we are going to put the one that we had before, I minus 1 and j minus 1. What does that be? It's going to be this one. This is I minus 1 and j minus 1. So we are going to put 1 here. So let's fill this up. And what's the minimum value here? 2. And quickly, as you see, we have r here and we have r here. Do we need to use this formula? Yes. What we are going to put here is gonna be 2 because we have repeated values. If we were using the first formula, we had to put 3 here because we get the minimum and plus 1. But because we have the same character here, we are going to put a matrix at index I minus 1 and j minus 1. Let's see how we can code this solution. What we are going to do, first we need to get the length of each word. Word 1, and it is going to be length of word 2. After getting that, what we need to do, we need to build up the matrix that we want. So matrix is gonna be, we are going to fill it out with 0 because we cannot leave it empty. N plus 1. Why n plus 1? As you see here, we are going to fill out the first row and first column by assuming that there is no word 1 for the first first column, and for the first row we are assuming that there is no word 2. So that's why we are going to have n plus 1 here, and we are going to say 4, and we are going to use n plus 1 here too. So let's print this out and see what we get. Print matrix. As you see, we are going to get an empty matrix m by n here. I'm going to put it here just for illustration purpose. You know that it's m by m plus 1 by n plus 1 matrix. This is what we have here. And then we are going to fill out this matrix with This, as you see, it starts from 0 to 5 and it starts from 0 to 3. So we can fill this out without having, because we don't have any previous values. So we are going to fill this out. For doing that, what we are going to do, we are going to say for I in range m plus 1, we are going to, for I in range m plus 1, we are going to say matrix at index, matrix at indexed I and 0. We are going to fill that with I, and we are going to do exact same thing for the we did it for the column, and we are going to do exact same thing for the rows. Right? Let's print this out and see what we get. We can print this out, print matrix, and see what we get. As you see here, we have the first row and the values for the first column. So for illustration purpose, I'm going to put this here. And as you see, this is plus 1 multiply n plus 1 matrix that we had filled out. And now we are going to iterate over the matrix that we just built, and we are going to use the previous steps to fill out the matrix. And we are going to have a for I in range m plus 1 and for j in range n plus 1. What we are going to do, we are going to, as I mentioned here, if the characters are equal, we are going to use this formula, and if they're not equal, we are going to use this formula. So we need to have this condition here. We are going to say if the word 1 at index I minus 1, right? Because we are starting from 1 here. So let me put 1 here and 1 here, right? Because we don't go through the first row and first column. We have already filled that up. If it is equal to word 2 at index j minus 1, what we are going to do, we are going to have at matrix I and j, we are going to have this formula, this one, right? And else, if it means the characters are not equal, what we're going to do, we're going to use this formula. Hopefully it works. I just copy and paste it, and we can check it later. And what we are going to return at the end, we are going to return the last cell of this matrix, because it's the minimum that we got by comparing all the previous steps. So we are going to return matrix minus 1, minus 1. So hopefully print matrix, so you can see how it looks like. Hopefully I've done everything right. Yes, you can see I've done it right, and let's put it here. As you see, we have filled out the matrix, and it's exactly equal to the one that we did it here, and it returns the right answer. We need to make 3 moves to get, as you see here, we need to make 3 moves. These are the minimum number of operations that we need to make to get Ross from horse, and the time complexity for this is because we have a for loop here, like we have other for loops, but we go for the largest time complexity, so it's going to be m by n, and the space complexity is going to be m by n, because we are having a matrix here. Thank you.